So in this video we're going to look at determining whether a matrix is an element of a given subspace. So it says consider the span of the set of matrices, the set of 2 by 2 matrices given by 1, 0, 0, 1 and 2, negative 1, 1, 0. And what we want to remember from the previous video is if we have a vector space like M22, which is the set of all 2 by 2 matrices, and what we identified in the previous video was that if we pull any arbitrary subset of 2 by 2 matrices out of this vector space, that set of matrices will form a subspace or a vector space in its own right. So that's what we're talking about here. The span of these two matrices is just the vector space formed by them, and what we want to remember is the vector space formed by these two matrices is just the set of all linear combinations of these two matrices. So all linear combinations of these two matrices that are drawn from the vector space M22 form a subspace. And so if we want to determine whether a given matrix is a member of this subspace, the span of these two 2 by 2 matrices, we just need to ascertain whether this matrix is a linear combination of these two. And this is something that we've been doing in this set of videos. So we look for scalars A and B such that A times the first 2 by 2 matrix plus B times the second 2 by 2 matrix equals this matrix that we're questioning membership in this subspace. And this is just a matter of going through and constructing the system of equations that goes with this linear combination. So A times 1 plus B times 2 equals 0. That gives an equation here. A times 0 plus B times negative 1 needs to equal 1. That gives a second equation here. A times 0 plus B times 1 equals negative 1 gives an equation here. And A times 1 plus B times 0 equals 2 gives an equation right here. And then once we have that set of equations, we can either try to figure it out through substitution or other methods, or we can just put it right into an augmented matrix where we take 1, 2, 0 and put it into row 1, 0, negative 1, 1, 0, 1, negative 1, 1, 0, 2, and then we put it into, for example, the computer algebra system, or by hand put it into reduced row echelon form. And in this case it's in reduced row echelon form. We have the A column and the B column, so we see that A equals 2 and B equals negative 1. So indeed this 2 by 2 matrix is a member of the span of these two matrices, where the span of these two matrices is just the subspace formed by them, the set of all linear combinations of these two matrices. So because 2 times 1, 0, 0, 1 plus negative 1 times the matrix 2, negative 1, 1, 0, because this linear combination generates the matrix 0, 1, negative 1, 2, we can conclude that this matrix is an element of the span of these two matrices.